Morning, everyone. How are you? Excellent. Thanks for coming in this early. 9 a.m. on a conference, not day one, is pretty early, so I appreciate you coming in. So today, we're going to talk about pragmatic DevOps and the how and why of that. So my name's Damian Brady. I work for Microsoft, the people with the pinball machine out there. I had nothing to do with that pinball machine, but it's very cool. You should go and have a play. And I've been told have a play before day 3, because day 3 it starts becoming really smart, and so you'll lose. So I work for Microsoft as a cloud advocate, and I talk about DevOps a lot. And so that's what we're going to talk about today, but this is kind of a combination of a whole bunch of talks that I often give around the ideas behind DevOps and how to actually implement it in organizations where it's a little bit harder. So this is pragmatic DevOps, and I just want to talk about that word for a second, pragmatic. So pragmatic generally means dealing with the reality of the situation right now as opposed to theories and the way that things should work. Right? It's about looking at what the situation is and reacting to that. But does that mean that we shouldn't think about the theory at all? And my premise here, and my idea here is that we should absolutely know the theory behind DevOps and what we're trying to do and why we're trying to do it. Because otherwise you can't be effective when you try to look at pragmatic solutions. So in short, you can't be pragmatic without knowing what you're trying to achieve and why you're trying to achieve it. Right? By way of example, my wife is an anaesthetist, or anesthesiologist if you're American watching this later. She's an anaesthetist. So every single day, she has a lot of decisions to make around patients who are going into surgery. And it's really common for her to have to make pragmatic decisions about whether this person is safe to bring into surgery or to have this procedure or to continue. Maybe they haven't fasted properly. They've eaten in the last 24 hours and they really shouldn't have. Or maybe they have not stopped a drug that they were supposed to stop before going in. Or maybe they just have a condition that nobody thought was relevant, but actually has some implications, cardiovascular implications and things like that. So she has to look at all of these things that the real world, like the situation right now, has served up, and then weigh up all the pros and cons, and the risks and the rewards, and decide whether that person should go into surgery or not. But more than that, also, are there things that she can do to still solve the problems she needs to solve in order to get this person under general anesthetic safely and back out safely as well? So she can't do that without knowing how all of this stuff works. She has a really intricate knowledge of the whole cardiovascular system, of drug interactions and what they actually do. But importantly, all of these guidelines, like make sure you don't eat for 24 hours beforehand, make sure you stop this particular drug before surgery. Blood thinners like warfarin and things like that are a great example of that. She has to know how they work, how you can mitigate that, and in the real world, can we continue and do something to manage that risk, but still meet the aims that we need to make, that we need to meet. Right? She studied for 16 years post-school to be fully qualified as an anaesthetist. Right? She was doing more study in a week than I have done in my entire career. And I'm not exaggerating there either. Like she would come home from work after an 8-hour day and study for 4 hours, 5 days a week, and then study for 10 on the weekends for months and months and months just to pass these exams. So her day job, what she does every single day is making pragmatic decisions, but she needs that underlying understanding of how the theory works, what these guidelines are there for and what they're trying to achieve in order to do her job. Right. So I'm going to talk a bit about theory and what we're trying to achieve and why, and I'm going to lean on a few different things today. As I go through and I start talking about these pragmatic things that you should do, I'm going to try as hard as I can to tie it back to these theories as well. So even if you're not in that exact situation where you can apply these things directly, at the very least you can say, well, I know what we're trying to achieve here. Maybe in my situation I can make some changes, think pragmatically, and actually solve the same problems. So what I am going to do today, I'm going to give you recommendations, ideas, practices, strategies, things like that. And I'm going to tie those back to these guiding principles. But I'm not going to tell you to use a specific product or technology. That is not really part of this talk. I work for Microsoft. You should use our stuff. But if you don't, great. Cool, I don't care. I don't get paid if you use stuff. I don't get paid specifically if you use more of our stuff. So use whatever works for you. And I'm also not going to give you any silver bullets. I'm not going to say, here's a problem that gets completely solved if you do this thing. Right? That's not how DevOps works. In fact, it's not really how anything works. So no silver bullets. The three pieces of theory or background that I'm going to kind of base this whole talk on are these three. We're going to look at Microsoft's DevOps definition. It's one of the better definitions of DevOps that I've seen. And then we're going to look at a couple of things specifically from Gene Kim, who is the author of the Phoenix Project and the Unicorn Project, which is coming out, and a couple of other books as well. I just find his stuff really easy to digest and very kind of to the point and clear about what the goals are. So he's talked about the 3 ways, which underpins the Phoenix Project book, and the 5 ideals, which is the ideas behind the Unicorn Project, which is coming out in about a month and a bit as well. If you didn't see as well, I mentioned on Twitter that there's all of these books that I've got at the end, which I highly recommend reading. I'm intending to buy a few of those for people, like 2 or 3 of them, if people have good questions on the way through. I have no plan, really, so just ask questions when they come up. So let's look at the definition of DevOps. So Microsoft defines DevOps as the union of people, process, and products to enable continuous delivery of value to our end users. Right? The most important word here is the highlighted one, which is value. Right? DevOps is not about delivering features, delivering bug fixes, delivering infrastructure as code, scalability, stuff like that. Those are all worthwhile aims, but the goal is to deliver value on a continuous basis. That means if you release a new feature and everyone hates it, you have not delivered value, right? So you need to be able to measure what's actually going into production and how people are using it. We'll talk a bit more about that then, about that in a little bit. So this is the definition. I'm going to talk about delivering value a lot today, right? And how we're actually doing these things and why we're doing them so that we are delivering value. The 3 ways is Gene Kim's kind of 3 ways of thinking about DevOps. These are kind of principles for the principles underlying everything that we do in DevOps. So the first way is systems thinking. And this is kind of the idea of the business to the customer or development to ops. You're making changes and that flow and that stream from doing the work through to running that work and delivering value to the customer, right? The idea here is to make sure that that flow, that stream of work, is as efficient and effective as possible. You know, no barriers in the way or as few barriers in the way as possible, but getting that flow from one end to the other to be as fast as possible. The second way, which is amplifying feedback loops, and it kind of is coming back the other way, right? It's the idea of when something is wrong, or if you want feedback about something, having that feedback loop be really effective. And the key here is being able to tie together the cause and effect. So we all know DevOps people talk about how it's really important that you continuously deliver changes. So you deliver small changes continuously, right, to production. And the reason is if you have to wait 6 months before getting this feedback of what's gone into production, you lose the cause and effect. You don't know what caused the problem you're seeing now because there's 6 months worth of work that's just gone into production. What's failed? Well, we don't really know. Something in that 6 months failed. So finding these feedback loops and amplifying the ones that matter rather than just amplifying logs and emails being sent to your inbox saying these things are broken, right? Amplifying the ones that matter so that you can actually get this cause and effect and react very quickly. So that's the second way. And the third way is having a culture of continual experimentation and learning. And this is the idea that it should be okay to try things, and as long as that feedback loop is effective, you'll be able to react very quickly. Right? If you don't have a culture that allows you to experiment, then you're not going to get better beyond a certain point. And we'll come back to that in a little bit as well. So those are the 3 ways, right? Systems thinking, amplifying feedback loops, and the culture of continual experimentation and learning. So let's talk about the 5 ideals. And this is a little bit more focused on development of software. Sorry, before I go ahead, the Phoenix Project is a novel that kind of explores those 3 ideas really, really, really well. It's a novel as well, like a story. It's not a textbook. It's extremely readable. I actually enjoyed reading it, so which is weird for a book about DevOps, but I would highly recommend having a look at that one too. There'll be links as well to all of the stuff I talk about at the end if you don't want to take photos on the way through. There'll be one slide that'll have a good link. All right, the 5 ideals. It's a bit more about software development in general. So the first ideal is the ideal of locality and simplicity. And the idea really here is if you want to deliver value as an engineer, as anybody doing anything, you should be able to do that from start to finish. The locality should exist such that you can make a change and it gets delivered out to production without you having to wait on 3 or 4 other departments. I was talking to somebody literally this morning at breakfast who just got an email saying, hey, when is this work going to be finished? And she had to reply and say, I can't do it yet because I'm waiting for you to make this change. Right? That's the opposite of locality and simplicity. Right? She couldn't do her work because she was waiting on somebody else to do theirs. If it's all complex and tied up with other teams, other departments, if you have to wait for the DBAs to run a script, if you have to wait for infrastructure to spin something up, you don't have locality. Simplicity as well is even inside your own environment. Can you just make a change, push it out and see if it works? If not, if it's really difficult to make changes, then you don't have simplicity either. So that's that idea. The second one is focus, flow, and joy. So focus and flow kind of speak for themselves. It means that you're able to focus on that, delivering that piece of value. Right? It's not this constant yak shaving, which is where you make one change, but actually before I make that change, I've got to change this system over here. Actually, it's not going to deal very well with this change that I just made because of this underlying database table. I've got to change that first. And there's another team over here that's probably going to be affected by that. Right? You don't have flow, you don't have focus then. Joy kind of comes out of that. If you're able to just sit there, who's a developer here? Just show of hands. Pretty much everyone, great. How many of you have sat there for like 3 or 4 hours before just coding and doing some work and getting something out, and then at the end of it you look at your watch and go, wow, I missed lunch, right? How good does that feel, right? And that is super productive. That you've had focus, you've had flow, and you've had joy, but most importantly, you're able to deliver value to the customer really effectively. So that's focus, flow, and joy. The third one is improvement of daily work, and this is interesting. This is improving your daily work even at the expense of your daily work. So this is a really common idea in a few different companies, Microsoft especially as well. Satya Nadella, who's the CEO of Microsoft, when he came in, one of the things he said really early on is, if you're ever given the choice between a new feature and improving your daily work, or improving the way that your system works, you should choose improvement every single time. Which is a fascinating way of treating software, right? And very counter to the opposite, which we see a lot of the time, which is, no, you don't have time to do that, we need to release features. Right? If you are constantly improving the way that you work, such that you can get locality and simplicity, focus, flow, and joy, if you're continually improving, that means in the future, it'll be much, much easier to make changes. It'll be much easier to actually deliver value to your customer or to your end user because you've improved your process. It's kind of like sharpening the axe, right? The good old story of somebody cutting down trees and getting slower and slower because the axe is blunt. Somebody says to sharpen the axe. You say, I don't have time for that, I've got to cut down all these trees. Right? If they actually improve their daily work, it has flow-on effects and amplifies itself, which means that you deliver better code, you deliver it better. So that's improvement of daily work. Psychological safety, and while it's super important to be not, I lost the word. It's important that nobody treats you differently based on your gender or your race or anything like that. But psychological safety is a bit more about whether you feel safe to raise issues or to make changes if you think things aren't going well. The opposite of this is these situations where something goes wrong and there's a scapegoat, right? Oh, we're going to actually fire that developer because they were involved in this project. We need to blame someone, so they're gone, right? What that means is people will bury problems. If there is legitimately something wrong or something that can be improved, nobody has the psychological safety to bring that to the fore, like to make that improvement or to bring it to people's attention. And that can be super harmful. Toyota, Toyota as a company gets talked about a lot in DevOps talks because they do a lot of this stuff. They invented a lot of these ideas. They have this thing called the and-on chord. So in their manufacturing plant, it's a big, big pipeline of different people doing small tasks and then moving on to the next phase. I'm not doing very well with words at the moment. I have a 1-year-old who came with me, and it's just me and him. If you hear a child screaming out there, that's him, right? So I'm a little low on sleep, so I'm forgetting words. This and-on chord is a physical chord that runs over the heads of all of the workers on that production line. There it is, production line. And the idea is if anything goes wrong, or if like there's a defect or a part that's not right, or even if they're not keeping up with the way the production line is flowing, the idea is to pull that and-on chord, and that alerts somebody and maybe stops the production line as well. Right? And this happens in all of the Toyota factories. There's a Toyota factory, for example, in Kansas City, I think, in the US. See if you can guess in a day how many times that and-on chord gets pulled. Keeping in mind, it stops the production line, right? Like 10, 20, has anybody got a guess? I just want to see what people think. Yep. 10, anyone higher than 10? 0? 0? 5,000. 5,000 times a day. They produce 2,000 cars a day out of that production line. The other part of this culture is that if somebody pulls that and-on chord, the line manager goes out to have a look to make sure it's not, it's actually investigating that there is a problem. But the first thing they do is they thank that person for pulling the and-on cord. It means that they've prevented a defect. They've prevented something bad going out. And there is this culture of, you have done a good thing because you have alerted us to this. So 5,000 times a day, there's a culture of being able to to bring these things to the fore if there's a problem, which is really cool. So psychological safety. The last one kind of ties it all together, is customer focus. Is what you're doing right now actually going to benefit the customer, or whoever your customer is, right? It might be great to improve your build server, add some RAM to make the builds a bit faster, but if you're doing nightly builds when no one's there, that's not going to improve life for your customer. Like, is the work that you're doing right now, hey, we're going to switch from React to Vue or something? That's really not going to improve the customer's experience. I mean, it might in a small way, and maybe that is a legitimate change. But if you're just doing it for technology's purposes, like because you want to play with the new stuff, is it valuable? Question? Yeah, so the question was, how do you prioritize the third one, improvement of daily work, with customer focus? That's a good question. They do seem like they're opposites, right? Should you improve your process in order to improve should you improve your process rather than doing a feature for the customer or a bug fix for the customer? It's about deciding whether this improvement to your process is going to, down the line, improve things for your customer because you can get features out quicker. If it's a choice between a new feature that a customer really, really wants and improving it so you can actually deliver that feature, it's up to the company a little bit. Microsoft would say improve the process first, because then that has flow-on effects later on. If you're always choosing features, then your system is going to become what's used in the Unicorn project. There's a word called complected, which I didn't think was a word, but I looked it up and it's a word. Your system becomes quite complected, which means it's very complex, has different dependencies all over the place. If you continually choose new features and bug fixes over improving the way your system flows and this idea of locality and simplicity, then you might get short-term gains, but the long-term ones will be much, much worse. So yeah, it is a bit of a toss-up. That's a good question. Come and see me afterwards. So that's the 5 ideals. The Unicorn project explores these ideals. Again, novel, really readable. I'm about 40% through. It's released in about a month and a bit. I think it's the 26th-ish of November. But if you go to the website, Gene's released excerpts, and there's 4 excerpts now, and by my calculations, that's about 60% of the book. So you can start reading it now and then buy it when it comes out. So that's a Unicorn project. It's really, really good. Right, so those are those 3 ideas, right? One thing that I think is worth mentioning, that keeps coming up is this idea of how DevOps is actually implemented in organizations. And I just want to touch on this because it comes up so regularly. There's three main ways that I see companies implementing DevOps in their organization. The first is to have a DevOps department that does all of the DevOps. Right? Does anybody have that here? Yeah, a couple of hands. Right. DevOps is supposed to be this union of developers and operations and anybody else who delivers that software such that they're working together to deliver a product. What we're trying to get away from is this lack of ownership where the developers write their code and then what happens after that is not their problem, right? Ownership is a really big part of DevOps. So you write the code, you should run it. You should have that locality, meaning that you are able to, from start to finish, decide how to deliver value to the customer and whether your code is delivering value to the customer. So we're trying to get away from these siloed arrangements. Having a DevOps department in between your developers and your operations department means that you've added a silo, right? You're making the problem worse. So a DevOps department that does all the DevOps. There's a great tweet about this. Having a dedicated DevOps person who does all the DevOpsing is like having a dedicated collaboration person who does all the collaborating. Which is a great quote. I love this. So DevOps shouldn't be a department, right? Now, does that mean you can't have a DevOps department? No, and I'll come back to that. The other way is that DevOps just becomes, oh, that's now what operations does. We just change their job titles. And we'll call it modern ops, and maybe they do some scripts to build machines rather than pointing and clicking. Maybe they use cloud VMs and Docker and things like that rather than what they were doing before, but that's still operations. Developers, your code just doesn't, like you write your code and then you hand it to them. Right? The other way is the other way around, where, oh, DevOps, that's actually now the developers. We don't need an operations department anymore because they can just spin up like Kubernetes clusters or something, right? These two ways don't break that cycle of developers and operations being on opposite teams. And that's really the goal of DevOps, not all of the intricate ways of implementing it. Right? The third way, which is, in my opinion, the right way, is a cross-functional end-to-end team. A team that has ownership and responsibility of everything from the ideas in the first place all the way through to running it in production and making sure it's delivering value. They talk to the customers, they plan the work, they write the code, they write the tests, they deploy it to environments, and they manage what's happening in production as well. And yes, cross-functional. There might be operations specialists and development specialists, of course, right? But it's this one team that has ownership. Now, if you have a DevOps department, they can still support this idea. If the DevOps department is kind of a knowledge base, a training department, that assists these teams in learning the technologies, doing things the right way, and then essentially sharing knowledge across the organization, that's a very effective DevOps department. If they're service delivery, as in they're doing the DevOps, that's the wrong way to go about it. If they're knowledge delivery, that's a great way of going about it. All right. I'm already talking way too much, so let's get into the actual, actually doing stuff now. So it's really difficult to work out how to just scattergun you with ideas and opinions and things like that. So I'm kind of going to arrange it in this flow of planning, writing code, or doing the actual development, testing, building, versioning, deploying to production, gathering feedback, and of course infrastructure, which underlies the whole thing as well. So we're going to talk about these ideas, and I'm going to give you some suggestions, ideas behind why I'm recommending those, and try to tie them back to these guiding principles that we just talked about. Before I start, are there any questions about what I've talked about so far? Any complaints that I'm not pragmatic yet? That's coming. We've done the theory. We've done our 16 years of training now in 25 minutes. Right, let's start with planning. So here's my first suggestion. Invest effort when you need it, particularly not before you need it. If you have a backlog that has 300 items in it, and they're all really meticulously built with, the story, like, as a something, I want something so that I can whatever, and 25 acceptance criteria and a description and screenshots, you may never do half of them, right? You haven't been delivering value, you've been delivering work. There's another idea in the Phoenix project of these 4 types of work. I haven't gone into that, but this is one of the bad types of work, right? Doing all this upfront planning, which is what Agile was supposed to fix. Doing all this upfront planning for stuff that you may never do in the end as well. So invest effort in building those stories out, or those work items out, when you need it, so just before you do that work. That means, of course, grooming your backlog regularly. So making sure that what's in the backlog actually represents things that you think you're going to do in the relatively near term. If you have an item in your backlog that you expect to do in about 4 or 5 years, there's no way you're doing that item, right? So grooming regularly means removing those stale items. If you have something which is so far in the future that it's not even worth thinking about now, just take it off the backlog. It'll pop up again if it's important, right? If you continually push something to the bottom of the backlog because actually it's not that important and you've done that for 35 sprints now, just get rid of it, right? If it comes up again, yeah, maybe pop it up to the top of the backlog, but you shouldn't be trawling through hundreds of work items, hundreds of stories that you may not do. So groom regularly and remove those stale items. If an issue comes up, like a bug or a change or something like that, it's better if you were the one who discovered that first, through your telemetry or through customer meetings. Any way of coming up with that, it's best if you learn about that issue before the customer does. I've been in projects before where I have a pager. This was a while ago. I had a pager. The pager was there so that you could get paged at 3 o'clock in the morning because one of the customers rang up and said, everything's broken, you need to fix it, and then yell at you for 20 minutes, right? It would have been way better if I'd known that the system was down before a customer did, right? So if there's an item in your backlog, how did you discover that item? If it's a bug, did you discover that bug through your own telemetry? If not, maybe add some so that you are the first to discover it later. Right? So this is something that you can aim for as well. If something comes up, try to work out how you can be the first to discover it. So this is really basic ideas about planning. Invest the effort when you need it, which means grooming your backlog, making it manageable, and removing the stuff that's not going to get done. Right? And then for anything that comes up, try to be the one that learns about that first rather than waiting for a customer to call you at 3 in the morning yelling. Right? So build that process so that you're improving your daily work is part of what this is about. Right? You can focus on what work that you're going to do and ignore the stuff that you're not going to do. And it means that your job is much, much easier when it comes to working out the stuff that you're actually going to put down in your application. All right, so that's planning. Let's talk about actually writing the code. I get asked a lot as well how to organize our repositories. So do I have a different repo for every one of my microservices? Do I have one gigantic repo that has all of the microservices in it? My thinking here, and this is my opinion, is that you should organize it by deployable unit. If you have to deploy 4 or 5 different parts of the application at the same time, they should probably be in the same repository. Right? Conversely, if you have different items that are completely independent of each other, having that code in the same repository just makes things a little bit more confusing. It makes the builds a little bit harder. You can't just say, build what's in this repo. You've got to say, build what's in this repo, but only under this folder. Also trigger it only if this folder changes, but not these bits because that's documentation. It makes it much, much easier. And it means that you can focus on the work that you're doing and flow. One small thing on microservices, if you have microservices that all needed to be deployed together, they're not microservices, right? This is what we call a distributed monolith. It has all of the negatives of being a monolith and all of the negatives of being distributed computing, right? Having to tie all these bits together. So if you have stuff in a repository and you say, I can just deploy this in that repository, that's a really nice way of working. It makes it much, much easier to work with. CI in the CI/CD stands for continuous integration, not continuous isolation. So this is an idea from one of the ThoughtWorks blogs, one of the ThoughtWorks guys. This is the words thing again. Martin Fowler, I believe. He talked about continuous isolation. And these are branches of code where you're doing a whole bunch of work. And then as you're doing that work, other people are doing other work on other branches. And these lines of code are being isolated from each other such that when you come to merge at the end, it's a gigantic disaster. You get this merge bomb. It's very difficult to put this stuff together. CI, continuous integration, the idea is to be continuously integrating the work you've done with the work other people have done. And if you're not doing that, if you're not continuously making sure that it all works together, then you're not doing CI. So what this means is short-lived feature branches or short-lived branches. Branching is fine, it's a great strategy, but if you're branching and keeping that branch active and distant from your master branch or your trunk branch for weeks at a time, you're doing continuous isolation. You're isolating that code and making it really hard to merge. What about changes that are really long-running? Like there are legitimately changes that take a very long time to do, right? My strategy generally there is to work out a way to write dead code. And this sounds a bit weird, right? Writing dead code means that you can write a whole bunch of code that doesn't really work yet, but that's okay because it doesn't get used in your production system. So my strategy for these long-running branches is first, branch for this new feature, do some re-architecture, some refactoring, such that you can write a new implementation of it that never gets used until you're ready, right? Then merge that back into master. So you've just refactored, kept all the logic the same, it's just that now you can write this dead code, this code that's not going to be run. After that, you can continually merge. You can push directly to master as long as you have some decent builds and things like that. You can continually merge and integrate your code with master because your code's not going to get run until you're ready, right? So being able to write dead code sounds like a bad thing. It's actually a good thing. It means that you can focus on the work you're doing and actually continually deliver value. Well, deliver value in terms of being able to write code without having to depend on other people to do their work first and so on. So write dead code. Question? Yeah, so the question was, is there a risk if you're doing that work, you're writing all this dead code, and then that code gets deprioritized, and now you've got this code in master that is useless. Do you go back and strip it out? So that depends on the organization. Facebook famously does feature flags for a lot of stuff, which I'll talk about in a sec. Feature flags for a lot of stuff where they write all of this dead code and then turn the flag on, and then the old code that now doesn't get run, they never go back and remove that. Or at least last time I read about their practices, they never go back and remove that dead code. Because they think, in their opinion, it's more risky to go and remove this code than it is to leave it in there and it not getting run. On the flip side, I don't know if you've heard about an organization called Knight Capital. Knight Capital Group was a company that did share trading in the US. This is a great DevOps story because you can name any one of like 4 or 5 things that went wrong. They had a feature flag that they used for a particular bit of code. They wanted to change the way they calculated trades or something like that. And they reused that feature flag. So the dead code was still there. They wrote new code and then flicked the feature flag across overnight when the market was closed to use their new code. So the dead code was still there. New code was now being used in production. When they deployed it, they deployed that change to 7 out of the 8 machines and turned the flag on. So this code that hadn't been run for years now was triggered again. So they had this dead code that essentially bankrupted the company in about 45 minutes. They lost $400 million in about 45 minutes. Because this dead code was there, they turned the feature flag on and pointed to that dead code, and now it failed. Right? So obviously, pros and cons to each. I don't have problem having dead code in production. I don't really mind that. If it is an issue, and I can understand why an organization would say we don't want dead code in production, I would, when you deploy that, I'd almost go back and automatically add a work item to your backlog that you are definitely going to do to remove that dead code once you've verified that all the other stuff works. So my strategy would be build it into your planning so that by this date, we need to have done this work to remove that dead code, and of course tested it and made sure it works through the pipeline. But yeah, there is a risk, is the short answer. That's a great question. I got to tell 2 stories, which is fantastic. Yeah, come and see me afterwards as well. It's going to cost me a lot of money in books. The other thing you can do if you have these branches is do things with pull requests. This is an idea in DevOps of shifting left. So the idea of shifting the discovery of issues as far left in this pipeline as possible. So if you think about it from idea all the way through to running in production, the earlier you can discover issues, in other words, the tighter you can make that feedback loop, which is that the second way of DevOps. The tighter you can make that feedback loop, the cheaper it is to fix, right? If you do builds on every pull request, you can discover these problems before the code even gets into master. The Azure DevOps team at Microsoft does everything with pull requests. They have about 600 pull requests a day, I think, from memory. And every one of those pull requests runs a build that runs roughly 80,000 unit tests. And every one of those tests passes. And if it doesn't, it's never going to get merged back into master. I'll talk about testing again in a little bit. But that means that they can discover issues before the code gets anywhere near production, right? So you're shifting this idea left, tightening that feedback loop. So these are the general ideas with writing code, right? Organize your code by deployable unit. It just means that you have that locality and that simplicity. It means you can do that work with just only caring about that repository. Make sure you're continually integrating, not isolating code from other code, which means short-lived feature branches. And I think it's a great idea to be able to write dead code. Write code that you can just throw away if it gets deprioritized. It's easier to throw that away as well if you've got this kind of refactoring with a new implementation rather than trying to change the old one. And then shifting left with pull requests and pull request builds. All right, I'm talking slow, or I'm talking too much, I think is the problem. We're going to jump over to infrastructure quickly. So the whole idea of infrastructure as code is to avoid avoidable problems, right? Your code doesn't exist in isolation. It needs to run on infrastructure. If production is this thing that eventually we will get our code to run on, and it's over there, and we don't have to worry about that for months, then there are avoidable problems that we're encountering now, right? Maybe it's not going to work in that environment, but we don't know that until long down the track when we actually deploy to production. This is an avoidable problem. If we know what that infrastructure is going to look like, we can test against that infrastructure before we get to production. I'll talk a little bit more about it later, but the idea of bringing production to the developers rather than bringing the code they write to production. We'll talk about that in a sec. Infrastructure as code means that you're able to do things like rebuild, patch servers, and verify that this stuff works before production. You wouldn't, as a developer, you wouldn't make a change to the code that runs in production by logging onto the production server and making changes to that code and then running it, right? And I see a couple of people looking like sidelong at colleagues of theirs. I have seen this happen, right? And if you have a load balancer with 2 versions of the code, you've got to make those same changes really quick, right? Log into both machines, change the code, save, change the other one, save, right? Just so it's consistent, right? But you wouldn't do that as a developer. So why do we expect that you would do that in infrastructure? Why would you go onto your production server directly and do an update and just hope that it works in production? Infrastructure as code and these ideas of doing that mean that you can rebuild your servers and you can patch them and you can verify that that's going to work before it gets to production. It also means that you can create reproducible environments, which is great not just for rebuilding production when it breaks, but also for building an environment that looks the same as production as much as possible before you get there. So you can actually test that the code that you write is going to work on that environment before you get to production, right? You can just spin it up. And you know it's the same because production was spun up using the same scripts. The key here is that infrastructure is part of your software. It should be treated as part of your software, not this thing that's over there that somebody else worries about, right? Your software runs on this infrastructure. It's intricately involved in everything your software does. You need to make it part of that development process. I'm not an infrastructure guy, so this is relatively short, but the idea is to avoid these avoidable problems. Enable yourself to rebuild servers, to patch them, and to verify that that works before you actually do it in production, just like you would do with your code. It allows you to create reproducible environments so that you can test before it gets to production. And remember that your infrastructure is part of your software. It should be treated the same way. All right. I'm going to continue, and we're going to leave questions till the end because we're at 40 minutes. Let's talk about testing. Key thing here, bugs are technical debt. If you leave bugs and say, we'll worry about that later, it's not high priority, this is technical debt. Having this process of writing all of these new bugs and then paying down that technical debt in one big, long process, it can be good if you have a lot of bugs to just stop for a bit, pay them all down. But if you can continually pay down this technical debt as you go, you get a bit more flow. It gets much easier to write that code because you have that locality, that simplicity now. You don't need to worry about, actually, this thing that I might change is probably related to that bug over there, and that bug uses this different thing. You know, you're accumulating this technical debt that makes your work harder in the future. So bugs are technical debt. Try and pay it down as early as possible. To do this, better is better than perfect, right? Don't think, well, we've got 400 bugs. We don't have any tests around stuff. There's no point me writing a test for this small bit of change that I'm making now because we don't have tests on anything else, right? Rather than trying to say, we need tests over everything, otherwise there's no point, try to say, we need a test over this thing I'm about to do right now because that'll make that little thing better. It's this improvement of daily work. It means nobody has to worry about that later on. One of the ideas which I really like for testing is red-green refactor. So this is the idea that if you encounter a bug, you should first write a test that shows the presence of that bug, so it goes red. Then you should fix the bug, make sure your test goes green, in other words, it passes now, and then do any refactoring. And it means that as long as it's still green, you know that you haven't broken that bug again. And this is the idea of better is better than perfect, improving daily work, and making sure that you can actually start to build up this list of tests or this group of tests that proves that your code has a bit better quality. You're paying down this technical debt as you go. Another thing with tests, all of your tests should pass all of the time. If they don't, then that's noise, right? That is giving you alerts about things that don't need to be alerted or that you don't need to be alerted about. There was a project, and a few people here may be aware of this project. There was a project where all of the tests failed on Tuesday because Tuesday the prices were different. But that's okay because we know that these fail on Tuesday. We'll just run them tomorrow and it'll be fine, right? That's horrible, right? You never, like on Tuesday, you never know whether you've introduced a bug, which is silly, right? The other ones are bugs that sometimes fail, so flaky tests. Sorry, tests that sometimes fail, so flaky tests, where if you run it a couple more times, it'll probably pass, right? You need to work out why that's failing and make sure it fails or passes every single time. Or tests that always fail, but that's okay, I know why they fail, we'll get back to that later, right? You want to avoid them as well. Like I said, the PR process for Azure DevOps, 80,000 tests roughly, every single one of them passes, right? And has to. That was a process. It took them a little while to get there. So, bugs are technical debt. To maintain the quality and to make it easier to write code in the future, it's important to pay down that technical debt as early as possible. That means better is better than perfect, right? You don't have to write tests across your entire system. Code coverage is an okay metric, that's fine, but by itself it doesn't mean anything, right? It just means that you have tests that exercise all of that code. It doesn't mean that they're actually being tested properly, right? So write tests where it makes sense and make it better than it was yesterday. Red-green refactor is a great strategy, and make sure that all of your tests are reliable. They pass every single time. If they fail, that means you've got a bug. It means you need to change something, right? Right, testing. Let's talk about building and versioning. This idea, which I came across at Octopus, where I used to work at, build once, deploy many. There's a lot of organizations, somebody was tweeting at me a couple of minutes ago, where they have a different branch for every one of their environments. The problem there is that you're rebuilding your code and putting it in a different environment, which means that when you build your code and put it in your test environment, you're testing that, making sure everything works, but then you're doing a rebuild and you're putting different code in production. And it may be, 99% of the time, it may be exactly the same because your branching strategy is fine. But it makes things a little bit more difficult to manage, right? You're testing different code. There was a .NET bug a while ago, in one of the minor versions where if you did a build of your .NET project in debug mode, it actually had different logic than if you compiled it in release mode, right? So people would build their project, deploy it to test, run through everything, it was all fine, build it in release mode, in other words, no debug symbols, deploy it to production, and suddenly it didn't work. Same code, just compiled differently, right? You want to make sure that the code you're testing is the code that's going to go in production. That binary that you've tested and made sure it works, that's what you've put in production. So build that once, deploy it many times. Only server builds matter. If you build on your machine and it's fine, who cares, right? That's your work in your environment. It's fine. That's not what's running in production, right? So your continuous build server, your build server, that's the build that matters. Right? I think that one kind of speaks for itself. Every single build should be identifiable. I've seen a lot of companies where they will do multiple builds for version 1.0.0, and they'll build it again, and that's also 1.0.0. You lose that traceability. You lose that feedback loop of what did we do that changed this code that introduced this bug? Oh, it was in 1.0.0. Great, there's 48 of them. Right? You need that feedback loop to be amplified so that you can do your work. So every single time you do a build, give it a new build number. I don't care what your build number strategy is, just make sure it's different and identifiable. The key here is that provenance is key. You want to know that this feature that you implemented, which resulted in this code change, which produced this build, which got deployed to this environment, you're able to trace that all the way back so that you have that feedback loop. You know, you have that cause and effect of what happened. If version 1 is deployed to production and there have been 35 of those and 300 changes in them, there's no traceability, there's no provenance of what made that change. So it's difficult to track that down. So build your application once, no branches for different environments. Happy to expand on that one-on-one if you want to later. Only server builds matter. Don't worry about the build on your machine. When you commit code, you should get a build that tells you whether that code worked with everybody else's. Every build should be identifiable because provenance is key. It's important to get that feedback loop to know what changed and what it broke. All right, deploying to production. Here's my first one. Production is a test environment. It's always a test environment. Right? Some people are lucky enough to have additional test environments before production, and you really should. But production is the first time this code is being run under real workloads in a real production environment with real people using the application. Right? You cannot fake that. Right? There is no way for you to actually really mimic what's happening in production. So pre-production is just a simulation. Right? And try and make it as good a simulation as possible. That's a very good idea. Right? However, remember that production is always the first time that it's being run in a real environment. What does that mean in practice? In practice, that means you need to make friends with failure. Right? Stuff is going to go wrong in production. It just will. Agile was this reaction against waterfall, which was the idea of if we do enough upfront planning, we will make sure that when we deliver this thing in a year, it's going to be exactly what everybody wanted. We know that doesn't work. Right? The same idea here. If we make sure we write our code really, really carefully and we have 100% code coverage and tests around everything and we put it in 5 environments first, run load tests and stuff, it will definitely work in production. So we don't need to worry about when it fails in production because that won't happen. Right? It's still going to happen. It just means that now you're not able to deal with that when it does. Right? This is that the third way of thinking. Being comfortable with experimentation and learn from that experimentation. And if you don't have a culture that can do that, when something goes wrong in production, everybody screams, the whole place is on fire. Right? It's a terrible situation. So be comfortable with failure. If you deploy less each time, there is less risk. So this is why we want this continual deployment, this deployment of small pieces every single time. If you are deploying 6 months worth of work every single time, the risk is all of that 6 months worth of work. If something goes wrong, there's a lot of things that could have gone wrong. Right? Every single time you deploy, there's a ton of things that you're deploying. Right? If you can deploy less each time, That means that feedback loop is much, much easier to deal with. You have that traceability of cause and effect. You know that what you changed is the thing that is now in production, therefore that's the thing that failed. So deploying less each time means that you have less risk and you have a better feedback loop. I talked about this briefly before, the idea of bringing production to developers rather than developers saying, we're writing this code and then sometime in the future it's going to run on that thing over there that we don't really know about, it doesn't matter. It's also not our problem. Right? The idea of infrastructure as code, even containers and things like that, the idea is to bring that production environment to the developers. Imagine if you were building a car and your team was responsible for building the engine, right? But all you have in terms of where the engine is going to go in this car is really detailed specifications, maybe even a great 3D model of what that car looks like, what the chassis looks like, how much room you've got to fit it in, what all the dimensions are, but you've never seen it. You don't get to touch that car until it's time to put the engine in it. How confident would you be that that engine that you've designed is just going to slot perfectly in and work immediately, right? I mean, you might get fantastic specifications, but I would not like to be in that position, right? That engine's not going to go into that car, right? It's the same thing with code, right? If you never see production, you get told what production looks like, that's fine, but you don't have it. When you put your code in, what's the likelihood that that code's going to work without a problem in that production environment? It's a better idea to be able to have that chassis, have that environment right there with you as developers so that you can actually test it before it gets to production and it's too late. So bring production to developers. Another great idea with DevOps is to separate the deployment from the release. So remember this write dead code slide that I had before? If you can separate the deployment of code and make that a technical event, so we actually put the code in production, it's ready to go, and then a release is just flicking a feature flag to turn that on, then that means that you can actually test in production, because production's a test environment. You can test it in production with real workloads, with real customers, before you release it to everybody worldwide. So if you can separate the deployment, make that a purely technical event, put that code in production, and then the release is turning a feature flag on, that can be really powerful and enable you to actually test things in a real environment before releasing it to everyone. Feature flags as well, fantastic idea. A feature flag, think about it as a glorified if statement. If I've turned this flag on, run this code. If the flag is off, run this code. It's pretty much all it is. And I mean, yes, there's more complexity when you actually get down to it, but really that's all it is. You're able to write dead code, but not run it unless a flag is turned on. That's pretty much all it is, but it's super powerful. All right, so all of these things. Production is a test environment. Anything in pre-production is a simulation, albeit a useful simulation, but that means you need to make friends with failure. You need to be comfortable with the idea that the code you have released and put in production is going to fail, so you need to put yourself in a position where you can identify that failure with the feedback loop, right? And then learn from that failure, which is the idea of experimentation and learning, and then react to it. Have that the first way of thinking of DevOps where you can make a change, push it all the way through. This ties into all of these things that we were talking about. Focus, flow, locality, and simplicity. If you can identify that issue because your feedback loop is good, make a change, and have the ability to push that change all the way through to production, then that makes for a much, much better environment and much better value for customers. You're fixing bugs quickly. You're identifying them quickly, and you're fixing them quickly. Deploy less stuff each time. That gives you less risk. Bring production to developers so it's not this car that you've got to fit your engine into at some time in the future. Separate the deployment of your code from the release of that code, and you can do that really easily with feature flags. All right, last one, gathering feedback. Customer focus is this fifth ideal, right? Make sure that what you're doing is actually focused on the customer, not focused on how employable you are as a developer, right? That's going to lead to better outcomes. I mean, make yourself employable, fine, but make sure that what you're doing day to day is actually focused on customer. This is a great t-shirt and a great phrase from Charity Majors. or I think it's Mipsy Tipsy on Twitter. Nines don't matter if users aren't happy. We talk about 5 nines with your application. It's great if your application's up, right? But if nobody's using it and everybody hates it, then the nines don't matter, right? Customer focus is really, really important. Yeah, you can get that shirt there, by the way, if you want. This third way of thinking, this hypothesis-driven development, meaning you think this feature is going to work for people and people are going to be happy with it. So let's try that, but let's also measure whether they are happy with it. Hypothesis-driven development is a great way of thinking about it. You're not delivering features you know are going to be successful. You're delivering features you think are going to be successful. And if you don't have a way of testing your hypothesis, then you really don't know whether it's going to be valuable to a customer. Definition of done. I love the idea that done means valuable. Or it's not valuable, but we learn something from it anyway, right? So either way, your feature or your work that you're doing is not fully complete until either the customer is finding value from it, or they're not finding value and you know why, and you can put that into your future changes. You know why that thing failed, therefore you can make better decisions about what you're doing with your application in the future. The key here is that if you don't measure what's happening, you can't know what's happening. If you are just expecting your feature to be valuable, but you don't measure whether it's valuable, whether that's asking customers directly, but they won't tell you everything, or whether it's doing things like, which the Azure DevOps team does, measuring when somebody turns a feature flag on, like tries out a new feature, and then measuring when they turn it off, or if they turn it off, and if lots of people turn it on and then turn it back off again, then start to drill into, well, why are they doing that? And that might mean asking customers. Right? But if you don't measure what's happening, you really don't know, you're just guessing. So there we go, these things. Customer focus, hypothesis-driven development, making sure that done means valuable. You have that ownership all the way through to production, including whether it's valuable. And if it's not valuable, that's fine if you learn from it. If you just scrap it and say, oh, the users don't know what they're talking about. Not customer focus, right? And then if you don't measure what's happening in production, you absolutely can't know whether it's valuable. So that's all of these things. I just want to revisit this, just to remind you. DevOps is a union of people, process, and products to enable continuous delivery of value. You probably heard me say value about 100 times during this talk, right? Value is the most important thing, right? Make sure you are delivering value, right? Gene Kim's 3 ways is a great way of thinking about the 3 things that really underpin everything we do with DevOps, right? Make sure you look at those. I would highly recommend the Phoenix project for investigating them a bit further. The 5 ideals from the Unicorn project is a great way of thinking about the different ideal scenarios we want to exist in our organizations to enable a good DevOps story and a good delivery of customer value, right? So these 2 books, highly recommend. That link at the top, which I think you can all see, damo.ms/ndc/pragmatic-devops, that has all of the links for all of this stuff. So that's the one thing you want to know. It's going to be on the next few slides, so don't worry about that. These 2 are from Gene Kim. I would highly recommend them. They're novels. They're not textbooks. They're fantastic. He also had a hand in the DevOps Handbook and also the Science of DevOps, the Accelerate book from Dr. Nicole Forsgren, who is an awesome researcher in this field. That's full of real-world research into this stuff. So you can legitimately say this is based in actual research, not in somebody's ideas of what should happen. Those are fantastic books. They're a little less novelly, but they're still incredibly good. I always recommend the State of DevOps report, the Accelerate State of DevOps report. That is a very digestible, I think it's about 70-something pages of real statistics and metrics around research from Nicole Forsgren and others as well. It's a great one to actually print out and put on a manager's desk if they don't believe in making change for DevOps. That's a fantastic one as well. Of course, the Continuous Delivery book, Jez Humble and David Farley. That's kind of the one that's existed for a very long period of time. It's fantastic. And yes, all of these links will be in that one URL. There's also some books from colleagues of mine, other cloud advocates. Effective DevOps, which is all about the culture of DevOps, which is fantastic, from Jennifer Davis and Rin Daniels. Emily Freeman just released DevOps for Dummies, which is actually a really good book, and it's not for dummies. It's probably very poorly named, but I think she kind of had to because it's a series. Seeking SRE as well by David Blank-Edelman is a bit more about site reliability engineering, making sure that everything keeps running and runs very effectively. These are all great books from colleagues of mine. That's the summary of the resources, where they all live. There's also a video show that I do at Microsoft on Channel 9, or DevRel Labs, I think it's DevRel Studios, I think it's called now, called the DevOps Lab, where we interview really smart people about stuff that they do. And then you can get hold of me on Twitter, DamoVisa, or damovisa@microsoft.com if you want to as well. All right, I see all the phones have gone down. Thank you very much for your time. I will be around here for the next little while, and when the next speaker comes up, I'll head just outside the doors. Thank you very much for your time, and you two come and see me. Thanks.